Hi guys, Igor here. Today we talk about test-driven development. So let's go. What it is? It's a development driven by tests. Basically, it's a technique of development where tests are a central part of development. So we write tests first or simultaneously with the code. Normally you either don't write tests at all, so good luck to you, or you write them someone later, and often you find that it's pretty hard because your design is complicated, your code is not really testable. So this approach tries to fix those issues, and it has many benefits also, which we'll cover later. And usually we have three phases here: red, green, refactor, and then we repeat them until we are done. And red here refers to the fact that first we write a test, it fails, that's why red. Then we write some code that make tests, given test pass, that's why we call it green. And then we refactor this code to make it better, more readable, and so forth, because it's not required in the first phase. In the second. In the second phase, green phase, we just write some code that make our tests pass. And what are pros and cons of this approach? So for the pros, the design of the code is simpler. That's because it's really hard to test complicated, complex, long code. So, and you will see that while you are trying to write tests and prove that it works. So, by the virtue of that fact that we need to write tests, our design is simpler. Obviously less bugs, and often we don't need to use debugger at all, because most issues can be solved during the writing of the tests. Easier maintenance and refactoring, because we know how our code should work. And also, if we are not the author of the code and the code has good test coverage, we can change it with the confidence, because we have the documentation in form of the tests, and we have a proof of the fact that it works. And we also gain confidence because we are proving that our code works. So we are confident that there will be no bugs, or if they will be easier to spot. We can add new test case and so forth. And what are the cons of this approach? So obviously you have to learn it, because it's not something that it's default, it's intuitive. It takes some time to get accustomed to thinking like that. And in the short term, you write code slower, because you need to get practice writing tests. But at the same time, you need to write more code, because you also need to write tests. So you will write code slower in the short term, because in the long term it's better, because code is more maintainable, flexible. You can change it with the confidence that it works, because you have tests. But if you need to write something simple, something that should work, I don't know, for a few times, for a few days, it's probably not worth bothering with this approach. But for anything that is important, I think that's the best approach to write code. And final one, if you have something infrastructure related, like database repository that needs to talk with the external database, or something that needs to call external API, this might require complicated setup and the usage of some external tools. But we'll also cover that in the next videos. Alright, so let's code something. So here we have a simple POM-based project, nothing fancy here. I have Java 17, and I have set up JUnit 5 as our test engine. All of the code will be in the GitHub repo, and I will link it in the description, so it will be available for you. So we'll write a class. I called it URL path parser, and what it needs to do. We need to provide two functionalities. It needs to parse for absolute and relative URL paths. So URL path is like that. So HTTPS, Google.com, for example, or just relative like that. And we need to have two functionalities here. First, it's to parse query params from URL paths, and query params are like that. They are a multi-value map. So in this example, we have key A, multiple values, key B, one value. So we need to have a map here. And also we need to cover relative paths, as I said, and cases where we don't have query params. This is the first functionality, first requirement. And the second one is to parse path variables from URL path as previously, and variables template. And the path variables are like that. So for this URL, path variable is here, is 1, and we need to have a map which is single value. So key corresponds to one value, and we need to provide template for that, because it's not like with the query params that it's known what the name of the associated variable is. Here we need to provide something like that. So the first argument is a URL, the second one is a template. And in that example, we know that we need to get this variable because it begins with the colon. And here we also have another example where we have two path variables. So we also need to support that. And in the case of non-compatible template, we need to throw meaningful exception. Okay, so let's start. We have nothing here. We just have URL path parser. So let's create a test class, because we will write tests first. So URL path parser test, the same package, and we will write tests. So I would start with the because we need to write tests first or simultaneously. I would start with the method signature. So for the first requirement, which is to parse query params, I would say that we need to have a query params method that can return something like that. So multi-value map, and we accept a path. We will not implement that, we just return empty map like that, and let's create a test for it. So let's say that query params given, let's say given path, or let's cover first case with the absolute URL. Given absolute URL should return its query params. Okay, and let's use absolute URL from example. So let's copy that. And we expect, what we expect, let's call it, let's create a variable expected, and we should get a should correspond to 1, and 12 as we have here, and b should correspond to list with one variable. So that is what we are expecting, and let's assert that this is the case. So assertions, and we will give it expected, and here we will call, or maybe let's also create a variable like that, actual URL of parser, and just assert that expected is equal to actual. It's not. This is the red face, as I described. We have a test, we have a method signature, but it doesn't pass. So let's create first implementation. What do we need? If path has query params, we know that we need to find this question mark sign. So let's say that I would say something like that. I will create a variable path query params and call path split by question mark. Right. Okay, it's regex, so we need to escape that. And here we have a path and query params. And so we can say that if path query params length is less than 2, it means that we don't have query params. So we return empty map like that, and in other case we have query params. So I would say query params, path query params, second index, which is 1. We have query params here, and what we should do, we have that. I would say that we should split it by ampersand. So let's say query params Parse, maybe, because this is really what it is. Let's split it by this sign, and here we have an array of this pairs. So we need to split them further by equals sign. So let's say query params pairs. We just iterate over that, and let's say key value query on pair split. Let's maybe call it like, I don't know, query param pair, and and we need to have actually a query params map, right? So query params map, hash map string and list of strings. We return that, and for now let's ignore invite input. So I would just say that query params that we have maybe key, which is this one, and value. And we just say that query params map compute if absent, because we can have multi-values related to one key. So we create new array list and we add next value to it. All right, and let's execute our test. Okay, it works. So right now we should either refactor it or add a new test. I would add this one more test. So let's copy that and say query params given relative should return this query params. Okay, and we just create something like that. Let's give it let's use different values. So I don't know, b value. Let's call it path. Let's maybe also execute it. It should fail. Yeah, it failed. Oh, improper path. Still improper. Okay, but right now it's good. Okay, it failed because we expected to see something else. Let's fix our expectation. And here be all right. Okay, so I would also add a test case to check what will happen if we I know if do we need to test for improper input. For now, let's see. Can we have more values here? I don't think so. Yeah, let's ignore it for now. Let's refactor this code. This is alright, I would say. Here we have query params pair. Seems reasonable for me. Split. Here I would say that if maybe key value length is more than 1. So that. Okay. Can we improve something? Query params map, compute with absent. Seems fine, let's say. Okay, so let's see if we can handle empty URL case. What will happen if we give it given absolute URL without query params? Without query params, turn empty. Maybe empty map. Let's see. Right, so path example.com. Let's say expected. Actually, maybe we should give it a type, but I don't think so, because right now, because of type reference, it's object. Let's see. And query params path. URL. Let's call it URL, because path is really a part of URL. URL is full. Expected actual. Yeah, it works. So let's also try with with the path. Okay, we called it relative URL. Yeah, I think path is better. Given your path, and here also given URL path. And let's give it a path like that. Oh, maybe something like that. Okay, it works. So let's say if we can refactor tests, I need to here we have different test case. Seems fine. Alright, so I think we can move to let's recap. We have gone through 3 stages. So we had red because tests weren't passing. Then we write code so that they pass, and then we did some small, but we did refactoring. So this method is implemented and it's working. So let's move to the second one. Let's cover second functionality, which is to parse path variables from URL path and variables template. So it will be slightly different, but let's call it, here we have query params. So I would say path variables, and here we need 2 arguments. So first is the path, and the second one is template. And let's return empty map as previously. Let's write a test which will be red from our phases. So let's say path params given absolute URL. How we have called, given absolute URL, and template should return path variables. Yeah. So let's also take absolute URL from example. Template is users ID, and we expect to have map with 1 key. And let's check what we get. Okay, red, as expected. So what do we need here? We have a URL and a template. So how we can know that we need to extract certain variable? I would say that we need to split to both path and a template by a slash, and then check where the variables are. Then we cover the exception. Okay, so let me show what I mean. This should be path parts. We split it by slash, and then template parts, and we also split it by slash. And I think we should iterate over that. Yeah. For now, we will ignore exceptions. I mean invalid input. So let's do something like that. Template parts. Template parts and part. Template parts. So we are just iterating over it, and we need indices. It will be clear why in a minute. So okay, and we have part. We need to check if this part is a variable or not. So basically, if part starts with this thing, it is a variable. So if this is the case, okay, we need to extract it. So if this is the case, we say variable name, I would say, and substring. We just need to take a substring starting from the first index. We just need to extract that. So yeah, variable name, and we have ID in the example from the test. And right now we need to take this variable from path. So let's say variable value, and this basically is same part but from the path. Obviously the path can be longer or shorter if the input is invalid, but we ignore this for this first iteration. So we have variable name and we have variable value. So all that we need is to put it in the map. So let's create a map, path variables map, call it like that. Here we return it, and here we will populate it. So variable name, variable value. Yeah, and our test should pass, I would say. It doesn't. Okay, why? Yeah. Because we have an offset in our indices with the here where we are calling split. Our first part is URL, I mean domain, and we care about that. So and it will be always the case because we expect a path to have this start with the slash. Okay. But let's see. Yeah, so I would say that we should create a method like a method to extract these path parts. Let's call it path parts from URL or path. And let's call it like that. And I would say that if path contains 2 slashes, we do something. In other case, we will just do it as previously, and in that case, we'll say new URL. Or maybe let's do something like that. Sanitized sanitize path. We ignore exceptions here. Something is wrong, it's just the path. And here do something like that. Right, because yeah, all of this complexity comes from the fact that we need to support absolute URL also. So let's call it. Let's check. Yeah, it works. So let's check path also, not absolute URL. But path. Let's maybe also take example from that. So let's rename it to path. And here we have template. Okay, and we expect to have order ID 12 and list ID equal to this. Okay, it works. So now let's refactor it. Okay, path. We have URL. Do we need to use it actually? Maybe not. Yeah, maybe we can do something like that. If path starts with we return that. Oh yeah, but we have protocol. Yeah, so it will not work. So maybe let's leave it. Let's leave it as this. So we have that. Template parts seems fine. Path variables map. Here we have if. Okay. For now seems fine because the case that will not work is that we need to throw meaningful exception in case of non-compatible templates. So to illustrate that, let's copy that. And let's say given absolute URL and non-compatible template should throw exception. And what we do here is let's create a template that is longer than URL. So I don't know, users /list, something like that. And here let's say that we would like to have something different, not expected, not actual, but we like to we expect that our method will throw meaningful exceptions. So throws, let's say that it will be just runtime exception. Well, of parser, here we call it. Template. Okay. All right, I know what we can do. We can do something like that. Here we have exception, and let's assert that exception message has something like that. Invalid template URL. Maybe invalid variables template. It is good for now. Yeah, as you can see, it is not the case. So what we'll do is that basically what we can do. Really, what we need is that here, let's say that if path parts length is, yeah, it comes down to that really, if you think about it. Invalid template. Let's improve it maybe. Invalid. Yeah, I would say that invalid variables template. Maybe let's add something which is more helpful. So like where has only path has only two parts, but 3 are expected from the template. Okay, and let's do something like that. Obviously not hard-coded, but from variables. Let's say formatted parts, template parts. Yeah, something like that. Okay, 4 are expected from the template. Oh yeah, because we have one here. So yeah, let's maybe refactor to this to a method. Yeah, can we actually? Yeah, because we also can support template without this, or it's maybe just maybe. Yeah, this will be enough for now. So one variable and this message. Hard-coded. Path has only 3 parts. Okay. Oh, yeah. Same thing. Okay. All right. So let's maybe refactor it a little. yeah, let's maybe put it to separate method, like validate path variables template. So let's give it a path and variables. Just include to that. Actually, path parts and template parts, both arrays. Okay. Let's check if test is passing. Okay, this. So what else? I think we should also check how path param behaves with the empty URLs. I mean URL and a path. So let's create a test case for that. So what I mean, path params give an absolute URL, and empty template should return empty map, how we called it previously. Yeah. We have here we have should, here we have not, so maybe let's refactor that. Okay, so should return empty map if we give it, I don't know, template like that without variables. Okay. Okay, can we simplify something here? I think if template parts are empty, can we? Oh man, it's not worth it. Theoretically, you can. If path variables are empty, also like that. Yeah, but it's not worth it, I think. So it is alright, I would say. Here, if path starts with colon, yeah, maybe let's put this into some kind of constant, like path variable prefix. Variable prefix. Actually, maybe also public query params prefix like that. Okay. Let's call our test. Okay, and let's maybe call all of our tests. Make sure. Yeah, and they are passing. Code is simple, as you can see. I think we have covered all of the cases. We went through all of the test-driven development phases. So yeah, I think this is enough for today. In the next episodes, because I intend to do a few of those. We also cover more complicated cases, because this was just a class that implements that does something in memory, doesn't have dependencies, and so forth. And in the future we also cover that. So if you enjoyed this type of content, like the video, subscribe to the channel, and I see you in the next one.